Simply, induction motor is a kind of motor which works on AC quantities. It's a kind of motor which works on AC quantities. It is of two types: three-phase induction motor and single-phase induction motor. Three-phase induction motor is widely used in industries. There's a lot of application in industries. Construction-wise, as in the case of all the motors, construction-wise it will have a stator part, and second it will have a rotor part. Stator is built for, or is constructed for, or it is housing three-phase winding in डेल्टा. अब ये डेल्टा में क्यों होता है? इट्स मैटर टू बी स्टडीड इन हायर क्लासेस. मतलब आगे जाओगे तो इसको समझोगे कि व्हाई द windings and why the construction of the stator is always in delta. Three-phase induction motor stator is always in delta. इस चीज की जानकारी हमें आगे को पढ़ाई में मिलेगी when we will dealing with the power system. ठीक है, और अगर इसकी जानकारी चाहिए तो पावर सिस्टम में जाके थोड़ा सा पढ़ो, you will get the knowledge of it. Now rotor basically three-phase induction motor का two types का होता है. One rotor is known as squirrel cage induction motor, based on the squirrel cage rotor. Based on squirrel cage rotor. मतलब रोटर के हिसाब से ही हम इंडक्शन मोटर को डिफाइन करते हैं. सेकेंड क्लास ऑफ इंडक्शन मोटर इज नोन एज SRIM, that is slip ring induction motor based on slip ring rotor. So induction motor are basically now classified as either a squirrel cage induction motor or slip ring induction motor based on the kind of rotors they are used to. So you can write from here. In construction, you can write now that basically three-phase induction motor are of two types. Based on the type of rotor, that is, first one is slip ring induction motor having slip ring type of rotor, and second is squirrel cage induction motor having squirrel cage type of rotor. So this is basically two types of induction motor which we have to study. और यही कॉमन प्रैक्टिस में यही दो इंडक्शन मोटर्स होते हैं, पहला स्लिप रिंग इंडक्शन मोटर और दूसरा स्क्विरल केज इंडक्शन मोटर. स्टेटर दोनों का सेम रहेगा जो कि थ्री फेज वाइंडिंग को हाउस किए रहेगा और डेल्टा में कनेक्टेड रहेगा, और रोटर दोनों के अलग अलग होंगे. एक का रोटर स्लिप रिंग टाइप का होगा, एक का रोटर स्क्विरल केज टाइप का होगा. तो उसके ऊपर हम आके देखते हैं कि हाउ द रोटर्स आर देयर, डिज़ाइन ऑफ रोटर्स, और स्टेटर के डिज़ाइन को हम देखते हैं. So construction स्टेटर पे हम मोटर है, स्टेटर पर हम सप्लाई देंगे, तो स्टेटर पर हम 3 फेज सप्लाई देंगे, स्टेटर पर हम 3 फेज सप्लाई देंगे। सो वी आर गिविंग द 3 फेज सप्लाई ऑन द स्टेटर, फेज ए, फेज बी and phase C. These are the 3 supply which we have given on the stator side. Now there will be having the 3 phases windings as A, B, C, as A, B and C. Now these 3 windings will be connected in delta only. These 3 windings will be connected in delta only. तो delta का कंस्ट्रक्शन क्या होता है, इस तरफ से होता है, तो क्लोज windings, these internal windings will be closed in delta only. So this way it is joined in delta only. Now this is the stator. Stator के बाद will come to see the rotor side. Now rotor side will be case 1 and case 2. Now case 1 will be squirrel cage induction motor. Squirrel cage induction motor का मतलब है कि rotor will be like this. It's a type of cylindrical rotor will be there, and these are the iron rods, or you can say the conductors which are connected, or rotor bars. These are the, this is a cylindrical rotor, and these are the rotor bars, or you can say conductors which are connected, and they are placed in the slots which are cut on the periphery of the rotor. These conductors or rotor bars are placed in the slots across the periphery of rotor. Now somebody wants to join, कौन है? एक मिनट रुक जाओ। ठीक, also these conductors are short circuited on one side. एक साइड में ये आपस में शॉर्ट सर्किटेड होते हैं, डायगोनली शॉर्ट सर्किटेड इस तरह से ये रहते हैं, ठीक है। नाउ सेकेंड क्लास ऑफ रोटर इज स्लिपरिंग इंडक्शन मोटर। तो सेकेंड क्लास ऑफ रोटर इज स्लिपरिंग, तो उसको हम देख लेते हैं उसकी डिजाइन कैसे है। स्लिपरिंग इंडक्शन मोटर, नाउ दिस इज द रोटर is like this. Rotor will be having the 3 phase winding connected in star, and from there this is the shaft of the rotor on which three slip rings will be connected. Three slip rings will be connected. And it is connected to the starter. This is the starter. So this is the rotor. This is slip ring induction motor, slip ring type of rotor. So these are the two types of rotors which we have to study in case of a induction motor. The stator construction is simple. Stator is having three-phase winding connected in delta always. That we have to remember. Stator always we have to remember that this always consists of three-phase winding, always connected in delta, So delta type of connection always there. Now this is the stator. Now rotor. First rotor is of squirrel cage induction motor. So in squirrel cage induction motor, it's a very simple construction, simple and robust construction. No maintenance, no cost. It's very cheap as well as simple and robust type of construction. There is a hollow cylinder. On either side there will be slots. In the slots we will place the rotor bars or the conductors. Now these rotor bars or conductors are short circuited on one side. Now second type of rotor is slip ring induction motor. This is a rotor will be having three-phase winding. This rotor will be having three-phase winding in star. Now the windings will be connected to three slip rings. This is the shaft of the rotor. So now windings will be connected across three slip rings, and then it is connected to the starter. So we need a starter to start the three-phase induction motor. Now we can do the comparison of cage and slip ring rotors. What is the advantage and disadvantage between the squirrel cage rotors and slip ring rotors? Slip ring rotors are also known as wound type rotors. Slip ring rotors are also known as wound type rotors. Now the topic is comparison between cage and slip ring rotors. So I'm writing in the point. First point is actually we are going to see the advantages of cage rotors So first we will see the advantage of cage rotors. Advantage of cage, or you can say squirrel cage rotors. Squirrel cage rotors over the slip ring or wound type rotor. So first advantage is simple. I have told you it is robust construction, no maintenance. Robust construction means we need very little or no maintenance, and cheap. Robust construction and cheaper. Second advantage is lesser maintenance, that is okay. Higher efficiency and higher power factor. Higher efficiency and high power factor. So we will discuss all these things in the coming topics, but from now we can remember it that it is advantage of squirrel cage rotors that it is robust in construction, means it requires less maintenance and it is cheaper, higher efficiency and higher power factor. Now the advantages of slip ring induction motor or wound type rotors is advantages of wound type or slip ring rotor. इसका क्या advantages है? First one is it has a high starting torque and low starting current. This is a very important thing which we have to discuss, और इसी पर फिर आगे का सारा टॉपिक रहेगा. High starting torque, and साथ ही साथ low starting current. Both are necessary feature of a motor. Low starting current, both are necessary feature of a motor. I'm saying that both are necessary feature of a motor. लो स्टार्टिंग करंट भी हमें चाहिए और हाई स्टार्टिंग टॉर्क भी चाहिए. तो ये दोनों चीज किसमें मिलता है? ये दोनों चीज मिलता है स्लिप रिंग इंडक्शन मोटर में. So this has to be remembered. ठीक है, this has to be remembered. Second point is we can add additional resistance can be connected in the rotor circuit to control the speed. Additional resistance can be connected in the rotor circuit to control the speed. All type of experiment we can do only in the case of slip ring induction motor, because we get a chance to connect additional resistance in the rotor circuit, so we can control the speed of the motor or rotor. So देखें कि हम एडिशनल रेजिस्टेंस कहाँ कनेक्ट कर सकते हैं. अगर आप ऊपर के सर्किट पर जाके देखेंगे, so this is the this way. This is the external resistance which we can connect in the rotor circuit, R external, and hence we can control the starting current as well as torque starting as well as speed of the motor. So we can control. These merits or these advantages are not with us in case of squirrel cage induction motor. So this much we have studied. Now next topic that we want to cover is I think it is torque speed characteristics. किसी को कोई दिक्कत बोलो?
No, sir.
No, sir.
Okay. So construction types होगी, torque slip characteristic is there. For torque slip characteristics, we have to study first of all what is slip. Until and unless we know the slip, we cannot go in detail about the torque slip characteristics. Now, as far as I'm one topic I am leaving. I'm not leaving. It has been done earlier also. See, for starting on working principle of induction motor. Working principle of three-phase induction motor. Three-phase induction motor. Working. Okay. Now, for this working of three-phase induction motor, we will take the case of, we will discuss the case of squirrel cage induction motor. Rest of the thing will be common. Everything is common in case of squirrel cage induction motor and Slipring induction motor. The only thing is that the construction of the rotors are different, but the principle of working is same. So what is the concept behind the starting of the three-phase induction motor that we are just going to discuss? So first of all, come here and see the construction. So let's draw the diagram. So this is the stator. This is the stator. So it will have three-phase winding. It will have three-phase winding, phase A, phase B, phase A, phase B, 120-degree displaced, and then we have the phase C, again 120-degree displaced. Now the windings of these three phases are connected in delta with respect to each other. So they will form a closed winding. Now, okay, fine. So ठीक है, these are the windings A, B, and C. Now, stated, then there will be air gap, and then there will be rotor. So rotor we have simple, our robust construction type rotor is there. This is the squirrel cage rotor, which is short circuited on one side, which is short circuited on one side. Okay, fine. Now it can be rotated across a shaft. Now, air gap. So what will happen? First of all, point wise, I will let you know each and every step. Phase A, phase B, and phase C. These are connected to the stator side. These are connected to the supply. This is again connected to a supply. This is again connected to a supply. So first step is that, first of all, just you draw it out. Now first step is a three-phase balanced supply is given on the stator side. Complete. A three-phase balance supply is given on the stator side. As soon as the three-phase balance supply is connected on the stator side, what will happen? Three-phase current will flow. It will flow across the winding, and three-phase current, what will happen? Second, three-phase balanced supply. First desirable condition, three-phase balance supply flowing through three-phase spatial distributed winding. So what will happen? It will lead to, बोलो, it will lead to the formation of क्या होगा?
Rotating magnetic field.
A rotating magnetic field. It will lead to the formation of a rotating magnetic field. कहाँ पर ये फॉर्म होगा magnetic field? In the
stator.
Air gap of the machine. ये बेवकूफ़ी मत करना. There will never be on the stator. Rotating magnetic field always in the air gap of the machine. So in the air gap of the machine between the stator and the rotor, there will be a rotating magnetic field. There will be a rotating magnetic field. Always in the space between the stator and the rotor. So this rotating magnetic field is rotating. Now let's suppose if it is rotating, then it will have a particular direction of rotation. So let's suppose it is rotating in this clockwise direction. So rotating magnetic field is rotating in the clockwise direction. Okay. Now it will have a speed also. At which speed it is rotating? What is the speed of the rotating magnetic field? Tell me.
Synchronous speed.
NS. That is the synchronous speed. So this is the speed of the rotating magnetic field. So synchronous speed. Synchronous speed means speed of rotating magnetic field. So the rotating magnetic field is rotating at NS, which is given by the formula 120 F upon P.
P.
So this formula you have to remember. This formula you have to remember. This formula you have to remember, where F is equals to, what is F? Frequency of supply on stator side, and P is the pole of the तो ये हो गया. नाउ यूनिट ऑफ एनएस क्या होगा? एनएस का यूनिट क्या होगा? सारी चीजें आप नोट कर लीजिए. आरपीएम. अब ये हो गया. नाउ उसके बाद हम आके कंस्ट्रक्शन वर्किंग प्रिंसिपल को समझते हैं. यहाँ तक हमारा काम हो गया. कोई नहीं. तो ये हमारा आउटर में आपका स्टेटर हो गया. स्टेटर, इसको 3 फेज दिखाना है, आप दिखा लीजिए, इट इज 3 फेज। इनर में आप छोटा सा रोटर दिखाइए। सो दिस इज आवर स्क्विरल केज रोटर एंड नाउ इसके बीच में वी विल बी शोइंग द, दिस इज आवर, let me draw with another color. This is our rotating magnetic field. ले नहीं रहा है यार। This is our rotating magnetic field, rotating in clockwise direction at NS. Okay, fine. Now, इसके बाद जो concept है, third concept is that once the rotating magnetic field is set up in the air gap, so rotating magnetic field will cut the rotor conductors. Will cut the rotor conductors. This is the point number third. Point number fourth. Now the rotor conductors are stationary and rotating magnetic field is rotating. So there will be a relative motion between the magnetic field and the rotor conductors. So there will be a relative motion between the rotating magnetic field and the stationary rotor conductors. So what will happen? What will happen? Tell me. If there is any kind of relative motion between the conductor and the magnetic field, so what will happen? So
EMF will be produced.
in accordance with the Faraday's law of electromagnetic induction. किसने दिया था? फैराडे ने दिया था. In accordance with the Faraday's laws of electromagnetic induction, and EMF will be induced across the rotor conductors. यहाँ तक क्लियर है? सो रोटर कंडक्टर्स जो रोटर इस टाइप का था आपका, जो रोटर इस टाइप का था, सिलिंड्रिकल था, स्लॉट्स कटे हुए थे. In the slots there were rotor conductors were placed. So across these rotor conductors an EMF has been induced. इसके across एक EMF induce हो गया, इसके across एक EMF induce हो गया. So now what will happen now? Also by the construction I have already told you that these rotor conductors are short circuited on one side. So these are short circuited on one side. तो इसका सर्किट डायग्राम अगर हम ड्रॉ करेंगे, सर्किट डायग्राम ऑफ द रोटर, इसका अगर सर्किट डायग्राम ड्रॉ करेंगे तो सपोज दैट दिस इज द रोटर. इट इज लाइक दिस. On one, this is the rotor conductor connected. This is the diagonally rotor conductor connected, and it is short circuited on one side. Now, by the action of rotating magnetic field, which is rotating at NS, an EMF is induced across this rotor conductor. So an EMF is induced. So let's suppose that this is the EMF. Take, and this is the rotor conductors. So a circuit of this nature will be formed. For rotor conductor, they will be having some kind of resistance, and it is connected. So a circuit of this kind of this nature is formed. This is the EMF induced. This resistance is for the conductor. Every conductor is having some kind of resistance. If it is a very good conductor, it will be having very less resistance. If it is an average conductor, it will be having a average resistance, but it will be having a resistance. Okay, so as soon as since it is short circuited, any EMF source which is short circuited will lead to the flow of a current. This is the rotor current. So rotor conductors will be automatically carrying a current. Okay. Now, after the rotor conductors are carrying current, we can say that the interaction of magnetic field and current carrying conductors क्या देगा ये current carrying conductors will lead to the application of force or torque, whichever is applicable. ठीक है ना? We define the Lorentz force. Lorentz force कैसे define होता है? What is the Lorentz force?
Sum of the magnetic field and
EF is equals
electric
to
field of force.
I dl cross B होता है ना?
Yes, sir. Magnetic force and electric force.
Electrical current is there, length of the conductor is there, and magnetic field is there. All these things are coming here. So there will be the application of electromagnetic force or electromagnetic torque, whichever is applicable. Electromagnetic force or torque. So with the application of this force or torque, the rotor starts rotating. So with the application of this force or torque, 8th point is with the application of this force or torque the rotor starts rotating. यहाँ तक सबको समझ में आ गया? Each and every point have been discussed quite vividly. How the rotating magnetic field is produced, and thereafter the rotating magnetic field will cut the rotor conductors, which will lead to the induction of induced voltages across the rotor conductors. Since the rotor conductors are short circuited at one end, so a current will flow in the rotor conductors, because we know that any circuit which is a source of EMF and it is short circuited will form a path for the current to flow. So there will be current in the rotor conductors. Now with the interaction of this current flowing in the rotor conductors with the rotating magnetic field, there will be a application of force or torque, which is given by the formula dF is equals to I dl cross B. So electromagnetic force or electromagnetic torque, whichever is applicable, will be produced, and in the influence of this torque or force, the rotor will start rotating. The rotor will start rotating. Now the question arises in which direction the rotor will rotate. The question arises is that in which direction the rotor or the motor will rotate. So this is the question. So क्या इसका आंसर होगा? फर्स्ट इसका अप्रोच क्या होगा? आंसर इसका क्या होगा? इसका आंसर के लिए we have to remember or we have to go through the or follow the what we already know as Lenz's law. So we have to apply Lenz's law. So where we have to apply Lenz's law? So we come and see where we have to apply the Lenz's law. So this is the, suppose that this is the rotating magnetic field and it is rotating in this direction at NS. Now this is, we consider inside it as a rotor. This is the rotor, which is now it is at a standstill. अभी ये रुका हुआ है. It is now at a standstill. Now the current EMF has been induced and now EMF has been induced and the current is flowing. Now once the current is flowing across the rotor conductors, with the application of torque, it has to start rotating. Now it has to start rotating. It has to start rotating. It will now rotate. It will now rotate. But it is confused at in which direction it has to rotate. So Lenz's law said that, Lenz's law क्या कहता है? The cause will oppose the effect. The cause will oppose the effect. Now it will rotate because of why it is rotating. Until and unless there is a current in the conductor, there will be no torque. अगर करंट नहीं है कंडक्टर में, करंट इन कंडक्टर, then only there is torque. ठीक है ना? टॉर्क के कारण रोटेट कर रहा है, तो टॉर्क के से पहले क्या था? करंट इन द कंडक्टर. करंट कहाँ से आया? ईएमएफ से आया. ईएमएफ कहाँ से आया? रिलेटिव मोशन से आया, रिलेटिव स्पीड से आया. किसके रिलेटिव स्पीड से आया? इट हैज कम बिकॉज ऑफ द रिलेटिव स्पीड. किसके रिलेटिव स्पीड से आया? टेल मी. Rotating magnetic field and stationary rotor. Now anybody can tell me? बताओ. It has come into the picture because of the relative motion or relative speed between the rotating magnetic field, which is at NS, which is rotating at NS, and a stationary rotor conductor, which speed is 0. Now the cause will oppose the effect. So the cause is torque and the effect is the relative speed. So torque will try to reduce the relative speed between the rotating magnetic field and rotor. So in order to reduce the relative speed between the rotating magnetic field and rotor, the rotor will start rotating in the same direction as the rotating magnetic field. So rotor will rotate in the same direction as the rotating magnetic field. So it will try to catch the rotating magnetic field, but will never catch. So what will happen? It will always slip away. So rotor will always slip away. So what is slip? S is equals to synchronous speed minus rotor speed upon synchronous speed into 100. So this is the percentage slip. Slip means what fraction of the speed of a synchronous speed by which the rotor fails to achieve the synchronous speed. Okay? More we will discuss in the next class. Till then, goodbye. Okay?
Thank you, sir.
Thank you.
Thank you, sir.
सब समझ में आ गया? नहीं तो फिर नेक्स्ट क्लास में हम लोग डिस्कस करेंगे. ओके, फाइन.
Okay, sir. Thank you, sir.
Thank you, sir.
ठीक.
Thank you, sir.